All right, continue our test 4 review. We left off at 17. It says write the first 4 terms of the sequence whose general term is given. We have to write the first 4 terms. So we're going to replace n with the numbers 1 through 4, generating the first 4 terms. So if n is 1, it's 1 here as well. And it's going to give us 6. A sub 2. 5 times 2 plus 1, that's going to give us 11. All right, and then let's gather up all these terms and just put them in sequence format. Okay, for 18 and 19, it tells us that the sequences given are defined using a recursive formula. That's because we see this n minus 1 here and n minus 1 here. Write the first 4 terms of each sequence. So I think I'll skip 18 and do 19 as our review. All right, it tells us that we can use this formula as long as n is greater than or equal to 2. Well, we already know a sub 1, so the next number we're going to use is 2 anyway. But to remind ourselves, what this is telling us is that to generate the second term, we've got to know the first term and then double it and then add 3. So if you can do this mentally, just by inspection, that's great. If you have to use the formula, that's fine too. So to find A2, n is 2 here, n is 2 here, but you subtract 1, so you get 2a sub 1 plus 3. So, but I know what A1 is. It's 5. So doing that work, I get 13. So the third term I need to get is going to be 2 times a sub 2 plus the 3. So the previous term was 13, so let's double 13 to get, well, here, let me just show it. 2 times 13 plus 3, so that's 26 plus 3 is 29. And how many do I need? 4. All right, so the fourth term is 2 times the third term plus 3. But the third term was 29, so 2 times 29 plus 3. I think that's 61. So let's gather up these numbers. So I think that was 5, 13, 29, and 61. All right, for this next group of problems, we're returning to factorials as indicated by the exclamation point. It says evaluate the factorial expressions, show all work. So for us to simplify this, of course you have a calculator and you can just do that if no work is requested, but if someone's grading the work, the process is find the bigger number at 17, detach the factorial, multiplying by one less number until you match the other number, reattaching the factorial so that we can divide out those factorials. And lastly, multiply 17 times 16, and that answer is 272. All right, on 21, by inspection, I see 14 is the bigger number. So let's expand with 14 until we get down to 12, reattach the factorial because of that 12 down there. So the 12 factorials will cancel. 14 times 13 and then divide it by 2. And I believe that answer is 91. It'd be better if I boxed it. We can kind of see what's going on here. 22, we've moved away from numbers. We just have expressions, but same process, same structure. What's bigger, n or n plus 2? I believe that n plus 2 is going to be bigger than n because you're adding 2 to n. So we're going to start there with the bigger number, but let's leave n factorial alone. Detach the factorial, so we've got n plus 2. Let's subtract 1 from 2 because the next smaller number is just going to be n plus 1. Let's subtract a 1 from n plus 1, so that gets us to n, and that's exactly what's on top, so we'll reattach the factorial. I've noticed I put this in parentheses, but it's no different than this one right here. So we can divide those out. So we still have a 1 on top. So our answer is a fraction, 1 over, and then I would not FOIL these because we lose the structure if we FOIL. So I would just record my answer as 1 over the parentheses n plus 2 times the parentheses n plus 1. All right, 23 and 24 says write the first 6 terms of the arithmetic sequence with the given first term A1 and the common difference. Okay, I think we can just do this by inspection. So if the first term is 400 and my common difference is 10, that just means I'm adding 10 based on the language of that question. I'm just always adding 10. Let's generate 6 terms and then we can walk away. 1, 2, 3, 4, 5. I believe we stop at 450. You can create a formula for this by using the nth term formula for an arithmetic sequence, but I think it's kind of intuitive just to do this. Okay, my first term is 190, but I'm going to continually add negative 60s, so the values of the terms are decreasing. So 190 minus 60 is 130, minus 60 I think is 70, 70 minus 60 is 10, 10 minus 60 is negative 50, 1, 2, 3, 4, 5, and negative 50 minus 60 is negative 110. So hopefully you find those intuitive and we don't have to create a formula to generate those terms. For 25, we're trying to find specific terms in a sequence, and here's the nth term for the nth term formula for a geometric sequence. Arithmetic sequence. I'm already moving on. Let's use this formula with this given to find the 80th term. So let's customize this formula first for this given. So a sub n is equal to 31 plus n minus 1 times the common difference, negative 5. And we want to find the 80th term. All right, looks like straight calculator work. And I got negative 364. All right, and just real quickly, same thing here. Let's customize the formula with the given. Now let's insert 20 for n. Do those computations, and I got 58. All right, problem 27. We're going to write a formula for the general term of the arithmetic sequence below. Then we're going to use that formula to find the 20th term. Okay, same thing we did up here. All right, so here's our formula. A sub 1 is the first term 2, and then we've got to figure out what's the common difference. So what we did was we took 2 consecutive terms, and we took the second one and subtracted the one previous. So 9 minus 2 is 7, 16 minus 9 is 7. Or you can think about going forward and just in your brain go, oh, 2 plus 7 is 9, 9 plus 7 is 16, so the common difference is 7. Okay, so we have to write the formula. So a sub n is equal to 2 plus n minus 1 times 7. Then we're going to use this formula to find the 20th term. And I'm going to jump up here. All right, looks like going to our calculator. I believe that's going to be 135. We're done. All right, we've got 28 and 29, and we're supposed to find the indicated partial sum of each sequence, and we're going to use this formula. So we want to find the sum of the first 20 terms of this sequence. So we've got term 1, 2, 3, 4. We've got a bunch of dot, dot, dots. We need to know what's in this 20 slot right here. Before I can use this formula, I've got to find the 20th term. So we're going back and doing what we did up here to find a sub 20 before we can find s sub 20. So it's kind of on hold for a minute. So let me generate the formula for this arithmetic sequence. So it's the first term plus n minus 1, and we can see the common difference is 7. Let me find a sub 20. And if I can squeeze it down here, the 20th term is 134. So now I'm going to go and find the sum of all of these terms right here, where the first term is 1 and the 20th term is 134, by using this formula. So now I'm going to customize this formula. So s subscript 20 equals 20 over 2. First term is 1, and the 20th term is 134. So the calculator gives that answer. All right, same thing here. We're going to add the first 50 terms of this sequence. Well, I only see 4 terms. A bunch of dot, dot, dots. I need to figure out what's in this 50th position here. So let's find that first. Let's find a formula based on this arithmetic sequence. So first term plus n minus 1. I guess I need to figure out what is my common difference. I believe I'm adding 8. Yeah, the numbers are increasing. Let's find the 50th term. And I got 374. That's not the answer to this problem. It's just that 374 is right here in that position. So now I'm going to go to this formula and find the sum of all these numbers. So the sum of 50 numbers equals 50 divided by 2, where I'm going to add the first and the 50th term. And if I did my math right, that's 8,900. Okay, so it looks like the remaining questions are a review of geometric sequences, maybe looking at particular terms of a geometric sequence, finding particular terms, and then probably adding a certain number of terms in a geometric sequence. All right, write the first 5 terms of the geometric sequence with the given first term and the common ratio. So I think by inspection we can do this. So it's 9. Then we multiply by 2 to get the next term, and so forth and so on. So 9 times 2 is 18. 18 times 2 is 36. Okay, that's 72. And I've got to do it one more time, 144. All right, same thing here. The first term is 243. We're going to multiply by negative 1/3. And you can do that on your calculator. Or you could think about taking the previous term and dividing it by -3. So that's going to be negative 81. Negative 81 times a negative number is going to be positive. Divide 81 by 3, I get 27. Divide 27 by -3, that's -9, and the last number will be 3. All right, in 3233, it says use the formula for the general term of a geometric sequence to find the indicated term of the following sequences with the given information. So here's the formula, and that's something you can have on your paper. All right, let's first build the formula and then use that formula to find the 10th term. So a sub n equals 4. Common ratio I would put in parentheses, and then n minus 1, I wouldn't have that in parentheses. 10th term, 10 goes here, 10 goes there. Just remember it's 2 to the 9th and then times 4. So the value of the 10th term is 2048. And I'll leave 33 for you. It's the same procedure. It's on the key. I think it's a rather small number, or you can think of it as a very large number if you ignore the negative sign, because you're taking -4 and raising it to the 9th power. Okay, 34. Find the 8th term of a geometric sequence having this first term and that common ratio a third. That's the same thing we did up here. It's just not telling me to use a formula. So if I'm going to find the 8th term, I've got to, first of all, create the formula. 65, 61, common ratio 1/3, and then to the n minus 1. And that actually turns out to be a really nice little number. It's 3. Okay, and for the last two problems, it says use the formula for the sum of the first n terms of a geometric sequence to find the indicated sums. So this is the formula we're going to use. This just represents we're summing, so we kind of ignore that. We just really are going to use this part of the equation. All right, we're going to find the sum of the first 12 terms of this geometric sequence. Well, this is term 1, 2, 3, 4. So we do not need the 12th term. There's nowhere in here that says that we need the 12th term. Unlike the sum of an arithmetic sequence where we do need that particular term. Oh, this one's not going to be bad. So S sub 12 equals, coming and putting 12 here, etc. So the first term is 3. But I do need to find the common ratio. It didn't straight up give it to me. How do you go from 3 to 6? How do you go from 6 to 12 and 12 to 24 when you're multiplying? That appears to be 2. Raised to the 12th power, close my parenthesis, and then 1 minus 2. And I believe if we do everything right, we get 12,285. All right, 36. Sum of the first 14 terms. The first term, 1 minus, I got to figure out what the common ratio is. And I noticed that the common ratio is going to be a negative number because I have alternating signs. I probably wouldn't mess with this fraction unless I had to. So just by inspection, what do you multiply 3 by to get -6? Likewise, what do you multiply -6 by to get 12? It appears that common ratio is -2. Raise that to the 14th power. 1 minus -2 down here. Be careful down here. And then my answer was 8,191.5. Okay. Anything we didn't do should be found on the keys that are going to be posted under class notes on Blackboard.